Hello students, I am Iñigo Arreitunandía, and today I will explain you the whole topics of physics and chemistry from 2nd of SO. By this I mean I will explain all the things that the teacher explains you during the whole year. Let's begin. So the first two things are the scientific method and some vocabulary. The scientific method has many steps, which are these ones. Identify a problem, research a problem, make a hypothesis, test the hypothesis, observe and record, and finally report your results. The vocabulary you need to know for this unit is hypothesis, an educated guess about the solution to a problem. Control, used to show that the result of an experiment is due to the conditions being tested. Variable, factor that changes in an experiment. Experiment, process to test a hypothesis. Conclusion, a judgment based on the results of an experiment. Theory, logical explanation for events that occur in nature. And finally, data, observations and measurements recorded during an experiment. Then the next following things are variables and graphs. There are three types of variables, which are dependent, that is the one that will change. The independent, it is the one that you give values to, the one that you change. And then finally control, the ones that you have to keep the same for it to be a fair test. The dependent variable is represented on the y-axis and the independent on the x-axis. Then there are four types of graphs, which are bar graphs, histograms, pie charts and pictograms. The first one here is a bar graph. The following one is a histogram, then the circle one is a pie chart, and finally the one is pictogram. You can use interpolation to work out values that are not shown on like bar graphs or scatter graphs. SI units. There are two types of SI units, which are derived quantities and base quantities. In derived quantities you have area, volume, density, velocity, acceleration and force, and the unit for area is meter squared, for volume meter cubed, for density kilogram per meter minus 3, velocity meter per second, acceleration meter per second squared, and force newtons. Then base quantities are length, mass, time, electric current, temperature, amount of substance, and luminous intensity. The unit for these quantities are the meter, the kilogram, the second, the ampere, Kelvin, mole and candela. Properties and changes. There are two types of properties and changes. Physical properties or chemical properties, as well as physical changes and chemical changes. Physical properties are the ones that are observed with the senses and where there's no change in matter. And chemical properties are the one where chemical reactions appear and when new substances are formed. Physical changes are when there is a change in shape, size, state or property from solid, liquid and gas. And chemical changes are the ones when new substances are formed. As you can see here, there is solid, liquid and gas, which are properties, and then the next following one is iron when it rusts, and when iron rusts, there is a chemical reaction, so it would be a chemical change. Hazard symbols. There are many hazard symbols which warn you about things that are in a scientific place. The first one is explosive, then oxidizing is like the one of flammable but with an O. The next one is flammable, then toxic, harmful or irritant. Harmful is an X with an H, and irritant is a cross with an I. Then corrosive, biohazard, dangerous for the environment, and radioactive. Some of these ones can cause skin rashes and skin burns, and also it can catch fire easily or it can explode. It can be toxic for the environment or for the human beings, and many other things. Then the periodic table. The periodic table is a table where all elements found are situated. The there are two main things, which are the groups and periods. The groups are the ones that indicate the number of electrons in the last layer and are the vertical columns. The periods are the horizontal columns and are the ones that indicate the number of layers of electrons. For an element, as you can see here, CO, the number above it is the mass number and tells you how much the atom weighs, and the number below it says the atomic number, which helps you to see how many electrons and protons thus the atom has. Elements, compounds and mixtures. Elements, they are made up of one type of atom. Then compounds are made up of two or more types of atoms, and mixtures are a combination of atoms, compounds, etc. In the first picture you can see an element, and the examples are oxygen, hydrogen, helium, carbon, potassium and sodium. Then the second one is a compound, which is a mixture of two atoms like salt and water. And the following one is a mixture, which is, for example, oxygen, hydrogen and helium, which is a mixture of air, milk, salad dressing. And here you can see the many pictures of how mixtures, compounds and elements are represented. Solutions. A solution is a mixture of a solvent and a solute. A solute is a soluble solid, and a solvent is a liquid in which you can dissolve the solid. The solvent here will be water, and then the solute, for example, sand. Water plus sand would equal the solution. The concentration is the amount of solid there is in a solution. There are three types of concentrations of solutions, which are dilute, where there's a small amount of solid, in this case sand. Concentrated, more amount of solid, more amount of sand. And finally, saturated, when the solvent, the water, cannot dissolve more sand, more solid. Separation. There are many separation ways to separate things, which are filtering, evaporation, distillation, fractional distillation, chromatography and decantation. Filtering is made through filtration and is to separate a solid from a liquid. This picture shows you what filtering is. Evaporation is made to evaporate things, and it is to separate a solid from a liquid to get the solid. This is a picture of how evaporation is made. Distillation is made by evaporation and then following evaporation, condensation, which is to separate a solid from a liquid to get the liquid. Here is a picture. Fractional distillation is evaporation and following evaporation, condensation, which is to separate a liquid from a liquid. Here is the picture. Chromatography is made with water or alcohol and is to separate two colored dyes. Here's a picture. As you can see, for example, red is made up of green and blue. And finally, decantation, it is made by precipitation, which is to separate liquids with different densities. Here you have it. For example, it would be water and oil. States of matter. There are three states of matter, which are solid, liquid and gas. In solid atoms are rigid, they have a fixed shape and fixed volume, and they cannot be squashed. In a liquid, atoms are not rigid, it doesn't have a fixed shape, but it has a fixed volume. It also cannot be squashed. But in gases are not rigid, they don't have a fixed shape, don't have a fixed volume, and can easily be squashed. The states of matter, here are our picture, and it's to change from solid to liquid or from liquid to gas. From solid to liquid, it's called melting. From liquid to gas, it's called vaporization. And from gas to solid, it's called deposition. If we do it the other way, clockwise, from solid to gas is sublimation, from gas to liquid, condensation, and from liquid to solid, solidification. Molarity. There are two triangles of formulas that you need to know. The first one is at the top, mass of substance. Then at the bottom you have molecular weight and number of moles. To work out the mass of substance, you hide the top one and you get molecular weight times number of moles. If you want to get number of moles, you hide it and you get mass of substance divided by molecular weight. The second one is similar and you have to do the same thing of hiding. At the top are moles of solute and at the bottom molarity and liters of solution. Atoms and bonds. All matter is made out of atoms and they are the simpler units of the universe. They are rearranged in chemical reactions and in one element they are the same but they are different from other elements. This is the Dalton's theory of matter, and at the bottom you can see a picture of how an atom looks like. It has the nucleus and then layers of electrons. The nucleus is formed by protons and neutrons, which have positive charge and 1 of mass, and electrons have negative charge and have no mass. Bonds. There are 2 types of bonds, ionic and covalent. Ionic are metals with non-metals and covalent are non-metals with non-metals. Metals give electrons and non-metals try to steal electrons. Metals are the ones on the left side of the periodic table and non-metals are the ones on the right side. Chemical reactions. There are 3 phases in chemical reactions. First one is word equation. For example, it will be lithium plus oxygen gives you lithium oxide. Another example would be sodium plus oxygen gives you sodium oxide. The second part would be symbol equation, which is the symbols of the elements. Li for lithium plus O2 is equal to Li2O. Oxygen always comes into 2 because they are non-metals. Gases always come into 2. Another example would be Na of sodium plus O2 equals Na2O. The third part is the balanced equation, which would be to balance all the stuff with sodium and oxygen. In the case of lithium and oxygen, it would be 4 of lithium plus O2. It would be 2 molecules of lithium 2O. Another example would be 4 of Na, 4 of sodium plus O2 would be 2 molecules of Na2O. Periodic table. As I've said, the left side of the periodic table from here up to here are metals and from here up to here are non-metals. Normally they are gases. The ones on the column, on the last column, are called noble gases, which have 8 electrons. For this year you only need to know the first 20 ones, which are hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium and calcium. Forces. Forces are pushes or pulls. They can change the direction of objects and change also the shape and size or speed. There are 2 types. Contact, which are, for example, friction, upthrust, tension, thrust, which is the opposite of upthrust, normal, and non-contact, which are magnetism, gravity, and finally static electricity. In this picture you can see the contact and non-contact. Formulas. You need to know many formulas for this year, and here are the ones you need to know. The first one is mass, density and volume. To work out density you have to do mass divided by volume. All of them are the triangles as I've explained before. Then this is force divided by E is equal to K. K is the constant of a spring and E is the extension. Then this is weight would be equal to mass times gravity, which you could also say volume times density times gravity, as volume times density is equal to mass. This is to work out the upthrust and Archimedes' principle. Then the other one is the relative velocities. If they are moving in the same direction, is velocity 1 minus velocity 2, and if they are moving on the other direction, is velocity 1 plus velocity 2. The other one is to work out acceleration or velocity. Acceleration is equal to a change in velocity divided by time, and velocity would be equal to acceleration times time. Then this is force is equal to mass divided by density. Then pressure would be equal to force divided by area, divided by surface area. Then mass would be equal to force divided by acceleration, or acceleration would be equal to force divided by mass. Then speed is equal to distance divided by time, distance speed equal times time. And then the other two are the ones for molarity. Newton's laws of motion. There are 3 laws of motion that this man here, Newton, made. The first one, an object with a constant position or constant velocity will remain at that constant position or velocity unless acted upon by a net external force. Then the next one is force is equal to mass times acceleration. Acceleration is produced when force acts on a mass. The greater the mass of the object being accelerated, the greater the force needed to accelerate the object. And the third one, action and reaction. For every action there is an opposite and equal reaction. Archimedes' principle. When a body is immersed in a fluid, that body displaces a volume of water. The weight of the fluid displaced is called upthrust. If the object weighs more than the volume displaced, it will sink. If not, it will float. As you can see here in the picture, this piece of metal is put into the water, and then the water displaced is here. So that will be called upthrust. This would be the formula for upthrust or weight. Weight is equal to force times gravity, or volume times density times gravity. Graphs. There are 2 types of graphs. Velocity graphs, which you can see that the area under the line represents the distance traveled, and distance graphs, which have a slope, and the steeper the slope, the faster the car is moving or you're moving. If the slope isn't as steep as it would be, the car or thing would be moving slower. Horizontal lines in distance graphs means that the car or you are stationary. This one, the first one, and the second one are velocity graphs, and the third one is a distance graph. You can see this horizontal line, which means stationary. Moments. The things you need to know for moments is that a moment is a turning effect on force. Forces can make objects turn if there's a pivot. The formula for moments is moment at the top would be equal to force times distance. For the moments to be balanced, this formula has to be used. Force 1 times distance 1 has to be equal to force 2 times distance 2. In the picture you can see that this boy here weighs more than this one and it's smaller, so to balance it, the weight of this boy times the distance between the pivot and the boy has to be equal to the weight of this smaller boy times the distance. Energy. The formula you need to know is this one. Energy mechanical would be equal to energy potential in blue plus energy kinetic. At the top, as you can see in this square, all the energy is potential as there's no movement. At the bottom, all energy is kinetic as there is movement. Mechanical energy is the sum of kinetic and potential. Potential energy at the highest point of something, and kinetic energy is at the bottom where there's no movement. If you want to know potential energy, the formula is mass times gravity times height. Then, to work out kinetic energy is 1/2 times mass times velocity squared. If you don't know the velocity, but you know the kinetic energy, you can do this other formula, which would be the square root of 2 times the kinetic energy divided by mass. Finally, the last topic would be waves. A wave is a propagation of a disturbance that transports energy but not matter. There are 2 types: mechanical, which propagate using matter, and electromagnetic, which propagate using vacuums or electricity. There are also other types to classify waves, which are transverse. The vibrations are perpendicular to propagation, and longitudinal. Vibrations are parallel to propagation. So the direction of the wave and the vibrations make this classify into transverse and longitudinal. If vibrations are perpendicular to the direction the wave is moving, that's transverse, and if vibrations are parallel to the distance, to the direction of the wave, it's called longitudinal. There are also sound waves, and a sound wave is a propagation of vibrating objects. And finally, echo is the reflection of sound. So if you shout near a cliff, the sound goes and comes back. The coming back of the sound is called the echo. Here you can see a wave, and these are the properties. The wavelength, which is the distance between 2 crests. The crests are the top part of a wave, and the draw are the bottom parts of a wave. The amplitude is from the middle point of the wave up to the crest, or down to the draw. The frequency is how high the wave is moving. So for example, if the wave passes this line really quickly, that's a high frequency. If not, it is not. The bibliography I've used to make this presentation has been the Physics and Chemistry book and Google Images. I hope you have liked this presentation and it has been really useful for preparing the final exam. And thanks for listening, and see you soon. Bye bye.